Hey everyone, in this video I will show you how to make this electric vortex effect. So it looks like this. So you can see that a vortex appear and it absorbs everything and throw it away like this. I can fire again. And we can also see the skeleton like this. We can also see the skeleton through the mannequin material. So like this. So here you can see that the skeleton is showing through the mannequin material also. So it will work with any material. So here you can see the beam connecting the sphere. Because I made the strength very low, we can also have different colors like this. And we can also have very high strength like this one. So that's insane value like this also. So this is what we are going to be creating today. And if you want to download the entire project file, you can support me on my Patreon. And for $5, you can download this and also download almost all my project files from my previous tutorials. And if you are already supporting me on my Patreon, thank you very much for supporting me. So to follow along, you need these resources. You can download them for free from the link in the description below. So you can either download them as a package project file or individually. So if you download the packaged project file, it is for version 4.26 and you will get these 4 assets. It also has a skeletal mesh that I created in Blender. It's really bad, but it's just for demonstration purposes. You can use your own skeleton if you want. If you have the same skeleton as a mannequin, you can also use that. And also it has this texture that I created in Substance Designer. This video is sponsored by Wingfox. Wingfox is an online learning platform where you can learn game art, VFX, graphics design, concept design, animation, environment design, etc. So basically you can learn everything you need for your game. And for Unreal Engine users, I recommend this course called Creating a Hack and Slash Game Prototype in Unreal Engine. So this course is created by Abraham Kim. So here you can see some of his works like this. So in this course, you will be learning the basics like installation and also the basic movement. You will also be learning hack and slash attack logics like attacking an enemy, and you will also be creating the AI for the enemy and also the enemy attacking the player, etc. You will also be learning level programming and progression. It is an 8.5-hour course and you can learn all of this like blueprint, combo system, enemy attack system, dodge system, character damage, etc. And if you use the coupon code WFR15, you will get 15% off of this course. So the links will be in the description below and you can check this out also. So now to start the tutorial, first we will create the orb. So in order to create that, we can just right click, then FX, then Niagara system and click next and click empty and press add and finish. I will call this NS center and open this up. So the first thing we are going to create is the distortion effect. So in order to create that, we can right click, then we can create a material and we will call this M_refraction. Then open it up. Then change the blend mode to translucent and change the shading model to unlit. And here for the opacity, we will give a value of 0. So it will be fully transparent. And now for the texture, we can go to the resource folder and bring these 2 textures in like this. And now get a lerp and 1 minus the red channel here like this. And connect this to the alpha and connect this to the refraction. So now we have the normal available and now we can connect the normal map to the normal and we can get this refraction like this. Now we need to control the refraction power using the Niagara system. In order to do that, we can get a particle color node and connect the alpha to the A here. So 1 is the refractive index of air, so it looks normal, and any value we give here will give a distortion effect. So anywhere there is white color, we will get a distortion, and that distortion we can control using the Niagara system, using the alpha channel. So now click apply, and now go to the Niagara system. Then here we can go to update and change this to self and make sure this is complete. And here we can go to the emitter update and type in spawn rate and set the rate to 1. So it will spawn 1 particle. Then we will go to initialize particle and set the lifetime to 1. We will set the sprite size to uniform and change the value to like 1500, or you can set a lower value if you want. And now for the sprite render, we can change the material. We can change the material to this refraction material like this. So now we cannot see anything, but now we can go to the particle update and we can go to scale color, and here we will lerp this alpha. So lerp and change the alpha to normalized age of the particle. So now you can see that there is some distortion happening. I will change the A value to like 0.5, so the distortion is more subtle. If I change this to 1, there won't be any distortion, and 0.8 or 0.7 will give a small distortion. We can change this to like 0.5, and now we can go to update again and type in scale sprite size and change this to a float value. We can use a curve to make the distortion smaller with age or the time. And here I will just select both of these and change this into a curve. And now I will just select the curve here and I will just move it like this. And I will select this and I will move it like this also. So it kind of gives this popping effect. Now we can create the absorbing particles. So for that, right click, then add emitter and click on view options, then click on plugin and engine contents, and here we can select the hanging particles, and here we will change the emitter loop duration to 1 and go to initialize particle and change this to 1 and 2 for the lifetime, max and min. Then for the color we can give a cyan color like this, 120. So now we have our particles. Change the scale to 2 and 5. We don't really need the box location. Also, for the sphere location, we can type in 3000. So it will be a really big sphere. And we can change the emitter to local space and change the sim target to GPU. And here for the fixed bound, I will just change this to like 1000 for all of them. So 1000 in negative and 1000 in positive. So our particles form de-render if we move our camera away, and we don't really need the curl noise force. Now we can just disable the scale sprite size, and now we can go to the drag and change this value to like 2 and change this value to like 20. So 2 for min and 20 for max. And then we can add a point attraction force. So this will attract the particles towards the center. And for the radius, I will give a value of 4000. And for the strength, I will give a value of 600. So now you can see that it is kind of moving to the center. But we want to kill this particle when it reaches the center. So click on kill radius and set this value to like 6 or something like that. So it kind of destroys the particle when it reaches the center. And now go to the sprite render and change the alignment to velocity aligned and go to update and scale size by speed and change this value to like 0.1, change this value to like 1 and change this to like 30 and change this value to like 0.5. So we get something like this. And now if I bring it into the world, it looks like this. We can also change this color to something a bit more bright, like 300 here. So if you really want to have some more bloom, you can go to the post process and add some bloom here too. Now we need to create the skeleton material. So if I just bring this skeleton here, we cannot see the skeleton through the mesh. Or if I just bring in a sphere and scale it up a bit, bring another sphere and put this inside, we cannot really see the other sphere. So in order to see the sphere, we can create a material. So right click, then go to material and m_scale and open this up and change this shading model to unlit. And that's all we need to do here. And now get a Fresnel node and get a lerp and connect this to the alpha here and connect this to the MSC color and press and hold V and click. So we get this vector parameter and we can call this color. So now you can see that how this Fresnel made the edges white and the center dark, because the position we are directly looking at will be black and the edges where we are not looking directly will be white. So now if we connect this to the B here and change this color to like this blue color, and now we can get a constant by pressing only one and clicking and connect this to the base reflect. And here for the exponent, we can give a value of like 2 or 8. We get something like this. So this is what we want. So now if I click apply and create an instance and add this instance to the second sphere, the sphere inside, we still cannot see the sphere. So in order to make this sphere come in front, we can go to the material again and we can get a world position node, this one. Then we can subtract the camera position from the world position. And now we have to normalize this. So now the values will be between a specified range like 0 and 1. And now we can multiply this value by a value called amount and connect this to the world position and click apply. Now if I open the instance and if I set the value to like -10 or -50, so now you can see that our smaller sphere is visible outside of the bigger sphere. So if I just decrease the value like this, you can see full, and if I increase the value, you can see that it is going behind the object like this. So find a value that works for you. And now if I add this to the skeleton like this, you can see that the skeleton is also visible through the mannequin mesh from all the sides like this. So this is what we are going to be using for the skeleton to be visible. Now we can also make the colors blink a bit. So we can go to the material again and here we can get a time node and a multiply node. And now we can get a scalar parameter by pressing holding S and clicking, and we can call this speed and change the value to like 5 or something like that. Then we can get a sine node and I'm just going to add 1 to it and multiply this by 0.5. So this sine values ranges from -1 to 1. So if I add 1 and divide that by 2 or multiply that by 0.5, so the new range will be 0 to 1 and not -1 to 1. And here we can just multiply this color, or we can just lerp this color like this and get another multiply and connect this here and connect this here. So with this we can control the minimum value. So here I will give a minimum value of 0.5 or like 0.2, so it won't completely go to black. I can change the speed to 1, so it will be very slow, or 10, so it will be very fast. Also I can increase the brightness. So here ignore the skeletons mismatching because the model is really bad. I made it really fast. You can also use your own skeleton mesh if you have one. it will work just the same. It just has to have this material on it. So the value 0 is better here. So if you are using just the 0 value, you can just connect it directly here like this and click apply. So it will work the same. And you can change the color to whatever you want. So now we will create the ragdoll effect. So open up the blueprint and go to the mesh. So here make sure that your skeleton has a physics asset like this one. And if you simulate this, you can see that ragdoll effect. So if you don't have the physics asset, you can right click the mesh and create physics asset. So now we will go to the third person character blueprint and here select the mesh. Then we can get the scaly mesh from the resources folder and bring that in and make this a child of this mesh like this. And here change the collision to no collision. And we can go to the construction script and here drag in the skeleton and type in master pose. So set master pose component and connect this here and select the original mesh of the mannequin and connect this to the new master pose component and just tick force update also. So now you can see that the skeleton is inside the mesh. So now if we add our material to it like this, you can see the skeleton inside the mesh. Now we will select this and type in visibility, untick this so it is invisible. Now we can go to event graph and here we can type in begin play and we can bring in the mesh like this and type in set simulate physics and tick this. And now if I go to the blueprint and bring that in and if I press play, you can see that it went below the ground. So in order to fix that, we can go to the third person mesh and here we can change the collision preset to physics actor, or we can just drag this and type in set collision enabled and change this to collision enabled query and physics. And if I press play, now you can see that he falls down like this. And if I go here and type in visible and take this and press play, you can see that our skeleton also take the position of the mannequin. So now you can see the skeleton inside the mannequin like this. So now I will just duplicate this third person character a little bit. So I have many. Now we will create the electric vortex that pull all of these things in. So we can go to the first person blueprint and go to the projectile. If you don't really have this, you can just go to add future content and go to this and add anything you want like this. So now open the first person projectile and here I will first go here and type in lifetime and set this to 0 so it won't die. And now here I will just disconnect this and now I will right click and type in begin play. Then I will add a small delay here and now I will right click, then type in custom event and I will call this stop. And here I will select the projectile and here we can type in velocity, then set velocity and make this 0 so the projectile stops. Also select the projectile and type in gravity and set this to 0. And now here we can type in call, stop and now press play. And if I fire, you can see that our projectile stops there like that, like this. And here when the projectile stops, we need to search for this third person character. You can do this in many ways. You can use a sphere trace, a multi-sphere trace, a collision sphere, etc. So there are a lot of ways to search for that. So here I'm just going to use another sphere collision. So select this collision component, then add component, then type in sphere collision, and I will call this search sphere, and go to event graph. Then here we can just drag this in and get a timeline, and we can call this search timeline. And now open this and select the length to 1 and add a float track. Then click here and set the values to 0 and 0. Click here again and set the time to 1 and the value to 1. And now we can grow our sphere. And here we can type in lerp and connect the lerp to alpha. And for A, the value should be 0. And for B, this is how big you want the sphere to be. So I'm just going to type in a value of 60. And now drag this and type in set 3D scale and connect this here. Now if I go to the sphere and type in hidden in game and untick this and press play, you can see how big the sphere grows into, like that. So after this finished growing, we don't really need the sphere, so we can type in destroy component and connect that there. So press play. Now you can see that it is destroying after it is fully grown. You can change the size by changing the value of the B. And now select the search sphere and go down to the on component begin overlap. So here we can do a lot of things. We can do cast to third person character and connect this to the other actor. And we need to drag and promote this to a variable. Disconnect this and change this to an array. Then delete that. Then bring that in again with get and compile. And here we will just drag this and type in add and add to array and connect this to here. So every third person character we encounter with the search sphere, we will store that into this array like this. Now we will go here and type in custom event and we can call this attract, and we will bring in the third person character array and we will do a for loop. So this will loop through all the elements in this array, everything the search sphere overlap with. We can now call functions inside the third person character using this. So we can go to the third person character and here we will just disconnect the event begin play, and here we can type in custom event and we can call this attract and we can connect this here. And now we can add a pin and we can call this location and change this to a vector, and here we can just drag this and type in add radial force, and for the location we can connect this, and for radius I will give a value of 4000, and for strength I will give a value of 20,000 or something like that. That will be really big. And tick acceleration change and we can go to the projectile again, and here we can type in call attract, and here the position should be this location of the capsule. So drag and type in get world location and connect this here. So now go to the timeline and here we can type in call attract. So this attract is the attract on this blueprint itself, this one. Now if I press play and fire, you can see that it fell down and it really didn't attract anything, but this function was called. So we can just give an insane value like this. So now we can see something happening. Okay, that was a bit too much. So we need to give a negative value. So we pull this towards the projectile and not away from it. So now if I fire, so it kind of bounced off of it. So I will just set the value to like negative 20,000. You can see a small nudge. So here what we have to do is that we have to continuously give the radial force towards the center or this location. We can use an event tick for that, or we can use a low frequency timeline. Since this is a physics simulation and it has inertia, so even if it only updates once every 10 frame, because of inertia it will still look natural. So we can get a timeline here, and we can call this attract timeline, and we can connect this to the play from start. And here we will just open this up and we will loop this, and now here we will add an event track like this and change the length to like 0.1, and we will add like event here like this one and click compile, and that's all we need to do. And here we can connect this to the new track, and now let's see how this works. So now if I fire, it isn't really pulling anything. So now in order to make this attract, we can go to the timeline again and add one more point here. And now if I press play and fire the projectile, you can see that it is attracting the character. So here if I go to the capsule component and type in hidden in game and untick that, you can see that the capsule isn't changing and we are still colliding with it. So we don't really want that. So in order to prevent that, we can go here and drag in the capsule component and set collision enabled and no collisions, and connect this here. And after when this simulation ends, we can set this to the collision again. So now if I press play, you can see that now we can go through this without any problem. And here you can see that the sphere is in colliding with the character. So in order to fix that, we can go to the first person projectile and we can go to the sphere, and here we can go here and drag in the sphere and type in set collision enabled, and here click this and select collision enabled. Now if we press play, now you can see that it is getting stuck to that sphere. We can also change this value to like 20,000, and now it looks way better like that. And now if you want to throw the third person character after a delay, we can go to the third person character and type in custom event, and we can call this throw, and we can also add a vector here and we can call this location, and here we can just duplicate this and connect this here and connect this here to the origin and change the negative to a positive. And now we have a new event. Click compile and we can go to the projectile and we can type in custom event and we can call this throw timer, and we will get a delay and we will set this to like 5 seconds, and here we can type in call throw timer, and when it is called we will just duplicate this and bring it here and call throw. Then for the location, it is this same one, like this. Now go to the third person character, and here with the throw, we need to get a sequence and connect this to the stop, and here we will get a small delay. So when this throw is called, we will stop this timeline, so it stop attracting and we can throw everything. So now if I press play, see, it is throwing, but if you want, we can have a very big value, so it will fly everywhere like this. So now just delete this Niagara particle system, and we can go to the first person character again, and here we can add a Niagara particle system, and this should be the NS sender we created. And now untick auto activate, and here we can go to attract and drag in the Niagara and type in activate and connect this here. Now we can see our particle system like this. Now we will create the growing sphere. So drag in the sphere mesh, then drag and type in set world scale 3D. Then get a timeline, and we can call this grow sphere and connect this to play from start, and open this up and change this value to like 1 and click loop, then add a float drag and click here and click here. Set this value to like 0.5 for time, and value should be 1, and these two should be 0 for value, and time should be 0 and 1. Now we can add a curve, like selecting all of this and auto curve. Now go back to the event graph, then connect this to update, then here drag and type in lerp, connect this to the alpha and connect this to the new scale and change this value to like 0.1 and change this value to like 1. And here after throw timer, we will just get a delay and destroy actor. So we will destroy everything after a 0.3 delay. So now press play. So now you can see it is attracting and moving the particle like that. So now we will just reduce the throw strength like this. And we can also make a material for the projectile. So we can actually use the skeleton material. So just duplicate that, and I will call this sphere. Then open it, and we don't really need the world position. Now click apply. Then add this to this sphere like this. So now if I press play, we can see that. Now we can add our skeleton. So we can go to the third person character, and here when we are getting attracted, we can select the skelly and we can type in set visibility and then tick new visibility, and that's all we need to do. So now we can also see the skeleton like that. We can also change the material of the mesh if you want. So if I drag this and type in set material and connect this here and duplicate this, and change this index to 1 because our original mesh has this element 0 and element 1 for the body and the chest logo, and this material can be whatever you want. So I'm just going to use a sphere material. So if I just select that and connect this here also, now we can get something like this. So here you can see that the capsule location is still the same location. So in order to fix that, we can go to the third person character, and here after the throw, we can have a long delay, like 4 seconds or something like that. In the description, I will also link a tutorial to do the Ragdoll Recovery effect. So if you want a more advanced version of this, you can also look in the description for that link. So now I will just select the capsule component and type in set world location, and this will be the location of this. So get world location, and now we can type in set collision enabled, and we can add collision again. So now if I press play, so after 3 seconds, the collision still be here. So now if I press play again, it will still work. Now we will create the connecting beams. So for that, right click, then FX, Niagara system, next, empty, add, finish, then call this NS beam, then open it up, then here go to update and change this to self, then go to initialize particle, change the value to like 1, and now go to emitter update, click add and type in spawn and spawn instantaneous, and change the value to like 12, and now select the sprite render and untick that and add a ribbon render. Then go here and type in beam setup and tick both absolute start and absolute end. Then go to initialize particle and go to color mode and direct set and change this to cyan color or whatever color you want. Then click this and spawn beams, and now click this again and beam width, and here in the update type in update beam, then go to beam width, and here we will just lerp this, and this alpha should be ribbon link order particles, and the first one should be 1 and B should be 5. So we get something like this. And for the ribbon particle, we can right click, then create a material and call this M beam, then open it up, then change this to unlit and get a particle color node and connect this to the MC color, and that's all we need to do. Then click apply, then add that to the beam. So we get something like this. Now go to update again and type in jitter position and change this value to like 7. So now it looks like an electric arc. And here we need to set this end location using the blueprint. For that we can go to user exposed and click add and type in vector, and we can call this location and drag that in here. Then click compile Then we can go to the third person character. We can select the mesh and type in Niagara particle system. Then change this to the beam we created. Then, like before, untick auto activate and go here like this and bring in the Niagara system, and here we can type in set activate and new activate and also tick reset, so next time we activate it will also show up. And then go here and drag this in and type in deactivate. So after we throw, it deactivates. Now one more thing we have to do is that we have to set this location. So drag this and type in set vector parameter and change the name to location. This is the name we gave here, location. Then this location should be this location we get from the sphere, or like the sphere location. So now if I press play, here you can see the electric beam like that. And I can fire again. So here you can deactivate the beams without the delay, so it will be faster. So if I connect this here and connect this here, and also we can select the skeleton and we can type in set visibility and we can make it invisible again. After it is thrown, so now the skeleton is invisible, but the color didn't change. So in order to do that, we can just duplicate this, bring it here, and for the first material we can type in male body, and here we can type in chest logo. Now if I press play, you can see that it is reset and I can attract again.